Ooh, look at this one. All right, what do we got? Okay, so let's just start whittling away at this thing, right? We've got a 3 and a 5, that's 8, because they're in series, right? And now I've got an 8 and a 17, and those guys are in parallel. Oops. Didn't need to do that. Okay, so let's see. So the 8 and the 17, let's do that. That is parallel, so I'm going to go left parenthesis 8 to the minus 1 plus 17 to the minus 1, and the whole thing to the minus 1. So 5.44 exactly. Isn't that awesome? Which is 136 25ths. I had to actually look into why that came out even, but there it is. All right. So let's take a look at this guy. The 7 and the 2 is 9. Right? And then the 11 and the 8 is 19. Okay, and now we have a 9 and a 19. So those guys are going to be, that's going to be parallel, right? So that's going to be left parenthesis 9 to the minus 1 plus 19 to the minus 1, right parenthesis to the minus 1. And that is 6.1071 ohms. Okay. And now we've got an ordinary circuit. We've got 52 volts pushing current through a 6, then a 5.44, then a 6.1071, and then 4 ohm. Okay, so now we can start solving for things. Okay, so let's solve A1. Let's see, A2, A3. Okay, so A1 I can do. A1 equals, I'm just doing voltage over resistance, and so that is 52 volts divided by a bunch of resistors, right? 6 plus 5.44 plus 6.1071 plus, and then finally the 4. Okay, I can do this. I know we can do this. 52 divided by left parenthesis 6 plus 5.44 plus, whoops, hold on, plus, and now I'm going to go up arrow and grab that 6.107 plus 4, and then end parenthesis. And that is 2.14133 amps. Okay, so that's this guy, 2.4133 amps. Okay, so let's see, we've got that. Now we can pick off some voltages. Okay, in particular, I can pick off V1, V2, and V3. Okay, now notice where V3 is attached. Okay, it could have been, I was just lazy when I did it. I could have attached it like this, right? And then like this, but it doesn't matter because this whole piece of metal is at one potential, right? That's just one piece of metal. It's all at the same potential. And this piece of metal, no matter where I connect it to. So it really doesn't matter where I connected this. It would be more clear if I'd done it like that, but I didn't. Okay, so anyway, let's figure out, V3 is the easiest one, but I'm gonna do them in order. Okay, so here we go, let's go. Let's find V1. V1 is IR, and it's this current going through this 5.44 ohm resistor. So it's 2.4133 amps going through 5.44 ohms. And that is, I can reliably say that's 13.1284. All right, so that is V1. Okay, and then let's find V2 just for kicks. V2 is going to be IR as well, right? Okay. And it's that same current going through 6.1071. Okay. So that's going to be this current, so 2.4133. And then this resistance here is 6.1071. Okay. Let me grab that. There's that guy times this guy. All right. That is 14.738. 7384. So 14.7384 volts. These are both volts. All right. Okay, that's V2. Let's do V3. V3 is IR. And it's that same current, 2.4133 times 4, right? It's only across the 4 ohm. If you go from this lead to this lead, right, you know, that's the only resistance you run into. So let's do that. This guy times 4. That's 9.6533. Okay, so V3. Okay, so now let's start getting down into things here. Okay, let's find the current for A2. A2 is going to be V over R. And the voltage is whatever I figured out for V1, that's the voltage that's across this, right? And the resistance is going to be 17 ohms, right? So it's going to be V1, right? V1 divided by 17. And V1 was 13.1284 over 17, okay? Because that's the resistance in the path of that current. That's the potential that exists from here to here. So I got to find that number there, 13 divided by 17. And that is 0.7723 roughly amps. Is that right? That is the current A2. Yeah. 0.7723 amps. Okay, so now we're getting down to it here. Let's see. We want to find A3. I think we can do that now. And A3 is right here. Okay. So A3 is also going to be this is going to be V2 divided by, and then the resistance in the path. So we know that that potential there is 14.7384 from here to here, and it's going through 9 ohms total, right? So that is, V2 is 14.7384 divided by 9. Let's find that. There it is. That guy divided by 9. And that is 1.6376 amps. 1.6376 amps. Okay, we're getting there, man. Then we got all these other annoying questions to answer. Okay, current through the 3 ohm. Well, let's see, 3 ohms. What is that? Where's the 3 ohm resistor? There it is up there. Well, that's not too hard. Current through the 3 ohms is, well, wouldn't it just be this voltage, V1, right? 13.1284, right? It's going to be V1 divided by 8 ohms is the total resistance in that path to that potential, right? So V1 is, where is it? Here it is, 13.1284 divided by 8. Let's find that. There it is. Divided by 8. And that is 1.6411 roughly. Okay, current is 1.6411. All right, so what's the voltage across that? Well, V is IR, right? So V 3 ohms is IR. And this is, we just figured out the current, right? So is 1.6411 times 3. Okay, that's 4.9231. So 4.923, it's 158, so 432. That's a 2 really. And that's volts, right? Okay, so let's see, voltage across the 7 ohm. Well, that's just going to be IR. We just got to figure out what I, what R, right? R is going to be 7 ohms because it's the voltage across the 7 ohms. So it's going to be the reading on A3, right? Times 7, right? So that is, let's see, A3 was 1.6376. And I'm going to multiply by 7. There's that guy times 7. And that is 11.4632. 11.46. Did we get that right? Yeah, 463. 11.463. Okay. Okay, what's the next one? Voltage, the current through the 8 ohm. All right, where's the 8 ohm? There it is. Well, that's going to be whatever this potential is divided by 19, right? That's the total resistance there. That's going to be V2 divided by 19. Okay, and V2 was 14.738. And then divided by 19. Let's find that. Where's the 14.738? It's up there somewhere. There it is. Nope. There it is. I found it. I just went up arrow and then divided by 19. And that is 0.7757. My poor computer here is like struggling with this. All right. Now let's see, what do we got? We are looking for the current through the voltage across the 11 ohm. Let's find that. The 11 ohm. Okay, where's our 11 ohm? There it is right there. Okay, so notice we've just found the current through the 8 ohm resistor. And now I'm asking you for this voltage, right? Well, the current through the 8 is also going through the 11 because that's a series circuit part there, okay? So I'm going to say that that is I that goes through the 8 ohm because it's the same current, right, that we just figured out there, this current, okay, times, it's the 11 ohms, right? Okay, so it's going to be 0.7757 times 11. We better get done here. This poor computer is ready to quit. Okay, that is 8.5328 volts. 8.5328 volts. Did we get them all right? Wow, it looks like we did. I was looking at the spreadsheet. Really, a spreadsheet is very handy for solving these because it's all just right there. All right. Woohoo! Baby! I fit it on the page.